PlexTrack is the platform that helps cybersecurity practitioners get the daily work done. Red teams can create reports in half the time and track risk to resolution with the blue team. Teams can centralize remediation efforts across all scans, assessments, and audits. Effectively communicate risk in real time through simple visualizations, scanner and ticketing integrations, and robust analytics. PlexTrack is perfect for collaboration across all teams. Visit securityweekly.com/PlexTrack to claim your free month. Want to be more thorough while also working faster? It doesn't matter if you're on the red or blue team, an augmented reality overlay can enable you to be more thorough and faster at the same time. No glasses, no goggles. Polarity delivers this superpower as an overlay on top of your existing workflow and tools. The free Community Edition connects to the data you care about to overlay the context you need to make informed decisions. Apply for early access today at securityweekly.com/polarity. The biggest problem in security that remains unsolved is flat networks inside the cloud and data center that allow threats to move laterally and compromise vulnerable targets. But microsegmentation using traditional firewalls is too complex and time-consuming. There's a better approach: Edgewise Zero Trust Auto Segmentation. Edgewise is impossibly simple microsegmentation. Using the identity of machines and software that are communicating, Edgewise offers the strongest protection that adapts automatically to changes. Protect any application in any cloud without any changes to your network by visiting securityweekly.com/Edgewise. Welcome back, everyone, to Paul's Security Weekly. Before we dive into it, a quick announcement. Joining me, Paraket, co-founder and CEO of Perimeter 81, and myself for a technical deep dive into the problems inherent in legacy VPN technology. Together, we will explore solutions for the modern workforce and how momentum towards a perimeterless architecture is helping redefine the future of cybersecurity. Register now by visiting securityweekly.com/perimeter81 / yes, did I say that right? I'm having a tough time speaking tonight. It's terrible. This segment is sponsored by Qualys. Visit securityweekly.com /Qualys to learn more. Join us for this segment, and no stranger to the show, I'm having a tough time seeing the teleprompter tonight too. I'm very challenged tonight. Hopefully Sumedh and Badri can help us out here and bring us home. Sumedh Thakar is the president and chief product officer at Qualys. Badri Raghunathan is the director of product management at Qualys. Welcome to the show, guys.
Thank you. Always a pleasure being here.
Yes.
Likewise.
Nice to have you. Yes, Badri, is your first time on the show. Welcome. I'm excited to talk about container security, as always. I mean, it's one of my most favorite things to talk about.
I love, Paul, that you stay hands-on with container security. Every time we talk, you always have spun up some container that you're trying to tinker with.
Yes. Most recently, I was hacking it and finding some really interesting things for my 2-hour mini training session I did on container security. So I'm always amazed as to how you can break containers. It's actually a really good segue into... And I even think it was John Kinsella, who's one of our hosts, who was at Layered Insight. It was like, containers really weren't designed for specifically security use cases. And I think that many organizations that use containers, similar to VMs and maybe some other technology, think that, they're just secure because they're a container and they should be separate. But that's not true, correct?
Yeah, I think just like with anything else that developers develop, it wasn't meant to be secure in the first place, right?
Yeah.
So containers were no different. I think it's a technology that is very powerful, and as always, IT rushes for the innovation to get it out for people to try it, and then security has to follow and come up with ways. And I don't think that inherently they were designed to be secure. Yeah, and when you get them out, that's when you start realizing how easy it is to get into them. And because you make it easy for ease of use and deployment, also kind of ends up making it easy for the hacker sometimes.
And it relies heavily on Linux primitives that I believe also fall in that category. It wasn't designed for security.
Yeah, and a lot of the Linux primitives are based on host-based security, right? So you in fact, you kind of obfuscate the fact that you have multiple containers that are running on a single host. So your SE Linux and a bunch of things are really meant for that host level thing. But then within that, they're communicating with each other, and that's meant to be sort of open. So that's a different conversation altogether.
Mm. Badri, you spend some time with customers at Qualys. In your assessment, what is their mindset when they're thinking about container security in general?
So today, what I would say we're hearing from customers is that it's more catch-up. To Sumedh's point, yes, containers are popular. Developers have adopted it. Now security is playing catch-up, trying to figure out how do we build this cat, so to speak, right? So they're thinking through what kind of security program could I put in place, and they're realizing what they had on the host side doesn't necessarily work. You have a pipeline. You need to think through this from a pipeline aspect. So again, no customer is the same. Customers are thinking through what does the program look like? How do I standardize my tool set across hosts, across containers? That's what we're hearing from customers.
It's really interesting as we segue into the protection aspect of it. And when I was at certain points in my container journey deploying an application, I was like, I'm going to be a good DevOps developer, and I'm going to patch and I'm going to fix everything, and all my Linux configuration, all my Linux packages, and all my software libraries are always going to be up to date, until they weren't, and it was going to hold up a release. And I was like, oh man, this is hard. And I think, me being a security practitioner, I was like, I really care about security. I live and breathe it, but I got to push this release out. And that means I can't update this library to fix this vulnerability, because that's going to delay the release by, a few days or a week. And so many enterprises and software developers are in that same boat. And I think that's one reason why runtime protection is especially important. Do you both find that true with your customers as well, that's one of the driving factors behind needing runtime protection?
Yeah, it's that eternal fight that we've always had between doing the right thing and doing it quickly, right? So there's, as you mentioned, you have to push stuff out sometimes, knowing that there's misconfigurations, vulnerabilities, whatever it is. Sometimes you don't even know that it exists, because you think you're pushing a clean image, and then as soon as the image goes out, people kind of download a little library here, a little library there into a container, and so now that container is something that's vulnerable. And sometimes, there may not be a software vulnerability or a misconfiguration. It's just the way that you've not thought about different attack patterns that might show up there. And so, I mean, the good thing about containers is that it's given us a lot of opportunity from a DevOps perspective, which you mentioned earlier, to be much faster at updating libraries and reinitializing all the containers after pushing out a new image, etc. But some of the most basic security-related issues just continue to stay. Could be just default passwords. It could be, allowing certain applications to look at certain files. That kind of stuff. It's the application was written too wide and too open so that any container could do anything. But the downside is that, a compromised container can very quickly cause some issues. And that's where that runtime aspect of monitoring containers really is becoming very, very critical now.
What I found interesting when I was reading through some of the materials you had on some of your recent releases and features that are addressing these issues is I could package up and make what I believe is a really secure container. And then when it starts getting pushed out into other environments, maybe by the site reliability engineers and IT in SecOps, is they could introduce vulnerabilities in the way that it's run. I mean, all you have to do in Docker, for example, -- privileged, and now you're just throwing a whole bunch of security controls right out the window, even though me as a developer, I did a great job of making sure my code is secure.
Yeah, that's a great point you bring up. And I think Badri has seen a lot of examples of that day in and day out. But it's the runtime where the container is run becomes super critical. Also, right? As you said, I could be running that container in my AWS environment or like Fargate or something where you don't even have a Docker or a host or something like that, and that brings up some other challenges. And so the question really becomes, how do you kind of define a security that is tied to the container itself rather than the environment? So I'm sure Badri will agree to that.
Yeah, Sumedh, because this is education for a lot of the security practitioners out there who are used to it on the host side of things, right? It's not just about managing your vulnerabilities per se. To Paul's point, a simple flag on how you launch the container gives you more risks in terms of I have privileged containers running. I have containers running with what's called as outside root, right? You compromise that container, then you own all of the containers on there, right? So it just goes beyond what you've been used to doing on the host side of things, not just from things like root containers, privileged containers, but having to think through the diversity of environments that you mentioned, Sumedh, right? And the one thing we see security practitioners struggle with is how do you have a standardized tool set, security tool set that goes across all these environments?
Yeah, and what I find interesting on that point, Badri, is the number of, I have a lot of control and buttons and knobs that, to adjust when I build containers, right? I can go as deep as I want. I mean, I could basically build my own Linux distribution and control every aspect of that. However, on the flip side of that, that also introduces a lot of opportunity for me to make a mistake and have that lead to a security vulnerability. And I know you, in your role, likely work with a lot of Qualys customers and potential customers. How are they working that balance between, if I take what's off the shelf from Docker Hub versus I want to do that myself and have a lot more control? Most people land somewhere in between. And what's your experience?
Yep. So this is something large enterprises and small enterprises as well grapple with. And the model most customers are moving to in terms of their pipeline is you have the DevOps team essentially build what's called a golden base image. So let's say if you're using Ubuntu, you're using Alpine, Red Hat, the DevOps teams would be on a cadence where they would be building this base image every 10 days or whatever the cadence is. In fact, this is the same thing we do inside Qualys for our microservices as well. And then the application teams are really taking this container and building on top. So if you look at some of the talks we did recently at QSC, we actually go through some examples where the application teams are building on top of these base images, and there's a automated attack surface program in place in the pipeline where you submit it, it gets scanned by Qualys Container Security. You can make gating decisions based on this, right? So somebody like yourself, Paul, is quite sophisticated, and you can make some of these decisions. But in most enterprises, what we see is there's pressure around time and budget to be able to containerize a project, get it up and running quickly. They might not always have the luxury of doing the right thing. So it's pretty much a bloated software running on the host that's crammed inside a container. So then in that case, what they really need is some kind of security tool that goes across their pipeline that gives them this visibility and gives them a list of 10 things to do so that they can effectively manage what you were getting at.
And when you folks say that you protect containers at runtime, what does that mean? Does that mean the different deployment models, right? Does it mean it's a sidecar? Does it mean it's something in the kernel? Is there something I need to do in each container? Like, what does that look like?
Yeah, we explored a lot of different avenues there, and there's different ways that people have looked at it. There's a sidecar, there's the privileged container, and all of them we ran into sort of challenges with scaling or being able to, because sometimes what happens is that just managing the security tool and the fact that you need a container of the security tool running in your container environment on every node itself becomes additional work that you have to do to make sure, I'm running a Docker node. If my development team never told me that there's a Docker host on it, I never deployed my container for security as a sidecar on it. So now I've left it completely open. And so the approach we took was very unique. And this is, as you talked to John Kinsella earlier, and bringing in the layered insight approach was, we kind of went with the fundamental model that the security has to follow the container. The way to do that, that we felt was the most appropriate after talking to a lot of customers, was the ability for us to inject a layer in the container itself at the time that the containers are being pushed out, so that we always have sort of a mini agent, you may call it, which kind of goes with the container. So no matter whether the container is spun up in AWS, it's spun up in Azure, it's spun up on a Docker host, what is the behavior that is allowed and not allowed in that container goes with the container. And so we took an instrumentation approach, which Badri can talk at length about on how that works. But it's an interestingly different approach that we have taken on that one.
And I like that approach the best. So I'm just going to be honest with you, because it goes into my build process, and I think we try not to use the word agent, but it's hard not to. But Sumedh, I think you described it very accurately. It's in the layers inside of the container. So it's just like you would install any other library or binary when you're doing your container build. Is just in there, and that process is so streamlined and can be automated and tested that I think it's the best approach from a deployment standpoint. I also think it's the best approach from a security standpoint, because I don't know where my containers might be spun up. I want my security inside of it wherever it's running.
Yeah, and you want it to be dynamic, right? One of the other things that we realize sometimes that when people love hey, I can build something and I can push it out, and if you try to build the security that way into the process or configurations upfront, every time you have a change to your security requirement, you're gonna have to build the whole thing again and push it out again. So the model that we followed was a very simple, lightweight, layered in approach, and then that piece of code is always connected with a centralized console. So that way, if you decide that I want to change my configuration, you don't need to respin or recycle your containers for the new policy to apply. It becomes instantaneous because the policy is immediately downloaded, and the containers will start applying that policy without having to go through a complete reunit and a recycle for that. So Badri, you can keep me straight here.
Mm-hmm.
Yeah, it's what I describe as autonomous protection, right? Where it's all baked into the image. And once the policies are in place there, it's functioning autonomously, right? It's sitting there doing its thing, allowing behaviors inside the container based on the policies that have been pushed out. And then the connectivity to the backend is really needed just to be able to get new policies or to be able to push policy violations in place, right?
Yeah, and it's an interesting question that's coming from the chat is, what's the difference between when you're building software and libraries and binaries into the images versus an agent? I mean, I think the lines are really blurred there, but I think we kind of dig into what an agent looks like when you're deploying to your desktops versus this small little library hook or binary that's running inside your containers. I think there's differences.
If I may, yeah, Paul, let me twist that question a little bit and perhaps get a little bit more insight. I think most people's aversion to agents typically are a concern about their the load that they put on the system, whether it's the performance or just the what it's generating, if it's some sort of an agent that's collecting data, that type of thing. So what is the difference in terms of what you're doing in terms of, or how do you put people's mind at ease that what people typically don't like about agents, they hopefully don't have to worry about with how you're approaching it?
Yep. So very pertinent question, right? I think if you think about terminology, the term the industry at large doesn't really use for containers is one around agent, because there's concepts people have around agents and aversions, rightly so. Here, the technical term we use is around instrumentation. And the approach we've taken is very lightweight, whereas it's focused just on monitoring and blocking what you choose to. So it's policy driven. You're not, at its essence, it's a syscall level firewall, and you're not sitting there and monitoring every function call that's happening, right? From a security standpoint, there's a hierarchy of things you need to do, right? So you need to be able to reduce the attack surface at the bottom of the pyramid, if you will, strip out all these unused libraries. And then for the remaining attack surface, for the libraries that you have, you have policies specifically geared for that part of the attack surface. So unlike an agent that's probably sitting there and looking at everything going on a traditional host, taking up a whole bunch of your CPU, taking up a whole bunch of your memory, this is very surgical, right? We don't want to defeat the purpose of containers. It's meant to be light. It's meant to be portable. So developers need to reap those benefits. From a security standpoint, it's a very lightweight approach that we've taken, and agent is definitely not a term we use, right? It's more instrumentation in this world.
Yeah, exactly. And it adds essentially to Badri's point, it's not a process or a daemon or something that's continuously running, which is typically how we define agents today, right? It's more of a library function level firewall that is layered in the code path, and it gets invoked only when that specific path is gone through, and it can make a quick decision and the execution can continue. And so that way you don't have something that's persistently running, so to say, which is taking up CPU cycles. It's only invoked when that particular layer gets invoked.
So what I hear you saying is you figured out a way to hide whatever load it does put on the system, because it's buried in everything else. I like.
Yeah, it's an approach of just layering on top, and that's what makes it pretty unique, rather than having something that's always running like a typical agent does, right?
Fair enough.
Yeah, it's different. I think people probably more often than not shoot themselves in the foot when they're building the containers and making them too large with other software that they're adding on top, or lack of understanding about containers. Building containers that are doing too much and not separating them out, I think will really hurt performance way more than. I mean, I've done a few different instrumentation style deployments inside of my containers, and my containers run just fine in every case. In fact, when it goes wrong, it's usually my code and not anything that I'm instrumenting to get any kind of other benefit, right?
Right. Exactly.
This is probably for another separate episode, Paul, but if you look into some of the containers that I use regularly, it just makes for a fascinating beverage conversation, right? You have Bash. Yes. You have Bash in this container. You have curl. Why do you need Bash or curl again in this container?
Well, and that's why I like the runtime protection inside of a container, because while I agree, Badri, right? Some people do leave a lot of utilities inside of their containers because they don't know how to do multi-stage builds, or they're in a rush. They probably know how, if they do, right? And they're not doing it because they want to get these containers pushed out to meet their deadline, so they're not doing a multi-stage build and stripping on all their tools. But even if you go through all of that, building a container that has a language, maybe like Python or Node and JavaScript, and even if I strip out Bash and curl and all those things, that language can be used by the attacker living off the land and be used for attacks. But by having that runtime protection, that gives me the granular control to say that those calls fall outside of the function of my application, so don't allow them. Is that how it works?
Yeah, I think the beauty of what, and the example you gave, and it's exactly that. It doesn't matter what language you use or whatever it is. Eventually, whatever language you use, it comes down to basic things, right? Opening a network connection. It doesn't matter whether you use Java or Python or whatever it is. You're going to ask the system to open a network connection. You're going to ask the system to read or write a file. You're going to ask the system to execute an application, and those things then, that's the beauty of that layered in approach, is that we don't really care what language is being used. What we look at is, are these basic calls being made on the system, and if they are, then are they in violation of a policy, right? Like, on this container, should I be allowing cat command to be able to look at your etc password file, right? Like, most of the time you're going to say no reason ever for a container to actually allow access to its etc password file, right? That when it's running, you could say something like, this container is a web server container. It should never be talking to any other container other than a database container, right? So no matter what language you use, when it comes down to that most basic level, that's where we operate to say, okay, this is not allowed by policy, and now we can block that without requiring a sidecar or a privileged container.
Yeah, and I love this, because I was doing some testing recently with some exploits that were manipulating file systems and mounting file systems, right? Some of the more basic exploits within containers. And I was playing around with, well, if my container is running as root, I can run the fdisk command. If it's running as a not privileged container, but not root, I don't have permission to run the fdisk command. But at the end of the day, it's Linux. There's probably half a dozen other ways where I can get direct access to something to show me some of the other disks. But with the runtime protection, it's going to say, no, this container does not have access to those specific functions. No matter how creative the attacker gets, it comes down to you can't call that system call.
Exactly.
I like that.
That's very similar to like the zero trust model for like containers. No.
Yep.
Yeah, that's a that's a topic that Badri and I, we had a bunch of these whiskeys, though I won't say what's in that, but we tried to stay away from some of that buzzword terminology that's out there right now. But if you bring it down to that basics, that's exactly what it is, right? It is that whether the fact that you had a container that somebody spun up accidentally as a privileged container, or whether it's a container that is not privileged, and there is some exploit that is allowing you to spin up something else, which is then being asked to open the file because your code is being blocked from opening the file. The point there is that you have a very specific set of rules, and you don't trust anybody except the allowed entities to follow those paths, right? So you're being very explicit about the fact that I only trust connections that are coming from these other containers. And typically that's the advantage of a containerized microservice environment. When you create the architecture, you pretty much have a very clear idea of the function of each container. So unlike a regular application that's running on a host where you have many different components that run on the same host, and those different components need a network, some of them need files, some of them need this or that. Containers, you kind of have one function that each container does. And so it's much easier to write these policies to say, okay, this is my backend report processing container. It does not ever need access to or from internet, or it does not ever need access to anything other than taking the data from this service, spinning up this application, and then pushing the data out to this other service, as an example. So the zero trust is definitely a very interesting byproduct of the approach that we have taken, because it does give you that ability to define only these things can talk to these other things, etc.
Yeah, and I like how you brought us in this direction, Sumedh, and it's kind of the next thing that I like about runtime protection is that when you run containers, spin up environments, whether it's in a cloud provider or Kubernetes, that's where you define the network, the storage, and which containers should have access to each other, and what parts of the network they're on, and what storage they have access to. And that's pretty easy to screw up. I mean, quite frankly, I think we used to have physical switches and firewalls. We had to plug things in and be very specific about it in a physical sense. Now it's all in configuration and software. Yeah. And I think having the extra layer of runtime that you say in these containers, my web server can only ever talk to the application server can only talk to the database server, and not only defining that in your configuration, which you can do in Docker or Kubernetes and lots of cloud providers, but building it inside the containers. I haven't been in the weeds in these configurations. That's something that I want.
Yeah, clearly. You look at the bane of the existence for security in many ways has been that whether it's an S3 bucket, all this beautiful latest technology obfuscates all the storage from it. And then ultimately the simple reason why it gets hacked is because you left it too open, or anybody could access that. And to that point. And that's kind of why I like your example that you brought up earlier, which is beautiful example about the fact that container that you spun up, you can spin it up with the privilege that you was never meant to have, and create all kinds of havoc on that system, right? So I think that's really where that runtime has been quite exciting for our customers, and I think this is something that Badri worked very closely with a lot of examples that our customers brought up for us to go in this direction versus trying to do a sidecar or something like that.
Mm-hmm. Badri, do you find customers are benefiting from being able to express and enforce those rules inside the runtime protection versus in configuration and benefiting from that extra layer of protection?
Definitely, right? I think it goes back to something Sumedh mentioned, right, where you can actually change these on the fly. So when in your pipeline, you can bake in the instrumentation, you can specify your policies. Let's say tomorrow you're actually changing something on your cloud provider itself, like you're actually moving this container into a VPC group that's publicly addressable.
Yeah.
You want some more reassurance and you want to be able to sleep at night with a few more controls that you want to bring in place. Guess what? You don't have to redeploy that container. You just have to push a new policy to that particular image, and all the containers that are being spun up from that image, they get that updated policy back from our backend. Right?
Badri, if I understand also that you could have the same container or the same image, have a few containers running on Docker, a few running in AWS, a few running on Kubernetes, on Google or whatever it is, but the policy will uniformly apply to all of them. So it doesn't matter where they run. It's the same policy, right?
Absolutely. I mean, it's all customer driven. For a customer who wants to do something like that, they have the ability to just apply the policy at like an image level, and it applies to all running container instances that stem from that image. Or if they say, I'm actually running a group of containers from this underlying image in like a staging environment, and I can have a somewhat less restrictive policy, they can choose to do that as well.
Yeah, and I love that because troubleshooting is hard because you harden the containers so much that I'm like, but I have an issue and I need to be able to try and ping something or use a command and it's not there. And I like to have different profiles, but make sure they're enforced as that goes through development and testing and production as well.
Yeah, we had that customer up in Portland. I remember that they brought up the issue that they had a nice system set up where they were doing some of these controls of who can access what and etc. At the service mesh layer, and then they said that the developers basically were relying on that. And when they decided to change their runtime environment and they went to a different environment and they went to a container as a service environment, all of that went out of the window. Like now they were completely open. They had anybody could talk to anybody, anything could read anything. And so that's the sort of the downside of relying on some of these service mesh type architectures specifically for this purpose, is that your container could change where it is running on the fly, and then you could you could be left open.
Sorry, Jeff, did you have a question or one from the audience?
Well, they're piling up. I've got a couple of questions, comments. First comment is, I want one of those mugs. Where can we get them? Second comment was, I thought the bane of every security professional was the vulnerability scan report. Just saying. Third, yes, there was a question on the Discord. It was somewhat of a rhetorical question, perhaps, but they said, "Sounds like this takes a very decent amount of time to configure?" Can you comment on the complexity of setting it up?
I think I can respond on all three. The first one is that this mug, I don't want to tell you because then Paul will stop inviting me to this program. So keep that exclusive. Number two is vulnerability report is the bane of existence. I think it's more for us at Qualys to keep up with the vulnerabilities than the customers. And I think the third part probably Badri can probably answer that a lot better than me. But the instrumentation part makes it significantly easier because all the configuration of the policy doesn't have to go as part of the deployment or the build. That can be done later. So Badri, I think you might want to jump in here.
Yeah, so I think that customer example that Sumedh was talking about, the customer in Portland, what came out of that was some great learning, which we've baked into the product. So customers like options. So we've given them various options. If you actually want to deploy, as a security team, you want to deploy a bunch of thou shall not best practice policies, right? Let's say based on the CIS benchmarks or something. So we have those out of the box written by a threat research team that you can actually push out. Or if you're saying no, I have some really fancy applications, I need something more custom, we have something really cool where you can actually run your containers in observation mode in, let's say, a staging environment or in production for a few days. And then with literally a click of a button, you can auto-generate a policy based on that behavior baseline we've seen. But going back to your question, does this take a lot of tender, caring love to configure in terms of policies and so on? No. We are giving customers lots of options depending on which end of the spectrum they're actually coming in from.
And I think for the part of there's two aspects to it, right? One is getting the instrumentation in place, and that's a blanket, simple little piece of code, and we provide a very simple way: point Qualys to your registry. We'll take the images, instrument the code, and we'll check in those instrumented images into another registry as an example, and then that registry becomes your official registry to spin up images from. So that's the aspect of putting in the instrumentation is extremely easy. There is really not, like, you don't need to do a lot of work around that, or you don't have to code, or you don't have to do any of that. Then the policy part, as Badri said, that all is defined, upfront in the application, and with a simple policy editor, or there's a bunch of default policies that can be put in observation mode. So that's the beauty of that, is that you can basically say, I want to observe the behavior of my container for a week, 2 weeks, and be able to see in the normal course of action, this container talks to these assets, and it opens these files, and it runs these applications. So after a week, I can say, make that as my baseline, and that's part of my policy, saying these things are allowed and these connections are allowed. And once you turn it on, then when something happens out of the ordinary, now it's automatically. So you can actually literally do this without ever having to even write a single rule yourself. You just instrument the container, turn on observation mode, 2 weeks later, click a button and say, whatever you have observed so far, that's my policy.
Yeah, so, I think a lot of the hard work is done when you're designing and building the containers and how they talk to each other. Like, largely that work is done. It sounds like what Qualys is helping me with is to be able to just define those rules so that it lives inside the container. Really, the hard work is done.
Because
right?
what happens, yeah, exactly. What happens is that the security team doesn't really know what is supposed to talk to what, right? At some point, you kind of you may not even be able to define all of that upfront. So what this approach does is that it lets you observe for a couple of weeks or whatever period you feel is right, and that's going to give you an idea of, hey, a given container in its lifetime basically talks to no more than these 5 IP addresses and does not execute anything else than these 3 applications, and doesn't read any other files than this one file. And so now that automatically becomes your baseline. So you don't even have to spend a lot of time upfront with your development team to define those policies to say what should talk to what. And now, once you have generated the policy, now your developer team could take a look and say, yeah, that's not normal. These containers should never be able to talk to these other containers. So now you can add these additional rules layered in. But the question about how you can get started without essentially typing a single character.
So what's the learning curve? And what support do you have to get folks this is brand new for them up to speed?
Badri?
So we just had our annual, we're just going through our annual Qualys Security Conference, and we've done a whole bunch of sessions in terms of walking through the offering itself. And one of the things Qualys is actually famous for is we actually provide free training for customers. So there's going to be a rich suite of training on qualys.com/training that gives customers a walkthrough for how the product works, how they can use it, beyond all the usual stuff you would expect around documentation and so on. We have a fairly seasoned team of technical account managers as well as solution architects who work with customers in terms of helping them conduct the POCs, helping them do the deployment itself, right? And to Sumedh's point, the instrumentation is super easy to bake in. We're also dropping a release later this month where we can give DevOps teams essentially a little CLI utility, and a developer can just run that CLI utility to be able to instrument things. We already talked about the policy pieces of it. So the list goes on there in terms of what we're doing today and how we are continuing to evolve the product in terms of giving them things like out-of-the-box dashboards where they can just look at it and operationalize this piece once they've instrumented it, once they've put the policies in place.
Doesn't sound like we need to beat a lot of people over the head.
Unfortunately.
That's the goal, right? Because otherwise it becomes very complex when you have so much to do for security to try to deploy its own consoles and all of that. So, I know the other thing is like we're generally pretty much always doing very long trials, free trials, right? You could come in, just sign up for an account and try the instrumentation work yourself. We're not one of those vendors that charge you for doing a POC, and that always gets me. But it's easy to try.
More questions? Jeff, did I hear you kind of?
I got a brief one.
Yeah.
I would be remiss if I didn't bring up my favorite topic. Sumedh, given your Qualys's legacy, sort of their bread and butter client base within the PCI world, how are you positioning this to the PCI customer?
Yeah, that's a very good point, right? PCI is all about compliance, right? And they require you to show that.
No, it's all about security. You prove it with compliance. But go ahead.
I said this last time on your program, right? That compliance is just a validation of security, right? So if you're doing your security right, it's very easy to prove that you're doing it right? When it's you have to play the games only when you're not doing it right, and then you have to find some things to do. But there's so many different terms we can use, right? But PCI, what's the number one thing that you require from a cardholder data environment, which is segmentation, right? The ability to show that your assets that are carrying cardholder data are segmented from other environments on the network, etc. So the approach really provides you very easy to showcase reports for PCI that can show your auditor that, yes, I have these segmentation rules already built in. The segmentation is done. The fact that the segmentation is at a whole different level. It's not even just based on a network. It can be done based on image IDs. And so that essentially really helps to showcase, like, there's a requirement for file integrity monitoring for PCI. So the same approach is able to showcase to you when you have that event mode enabled that shows you that your critical files are not being accessed by anything other than the approved binary. So there's, in fact, a lot of different things that we can use this for to show compliance against PCI at runtime, which is what they need.
Cool. I knew you would be able to answer the question.
Yeah, I'm glad you have that confidence.
I was also going to say, too, that, the PCI questions, I hope, have contributed to you getting that mug and maybe having something in it.
It has. That was the first thing I ever did at Qualys was work on that PCI. I even wrote a book, PCI for Dummies. So.
Not enough people have read it, apparently.
Yeah.
Outstanding. So the new container security features, are they? There's some resources that I have here in my notes, but where can people go to learn more? How do they get a trial or test it out and all that kind of stuff?
So there's a blog post that we actually put out last week around the general availability of this offering that talks about how the product works. There's screenshots in there. There's product documentation that will make for very interesting Friday evening readings where people can go look at it. And as with the Qualys product philosophy that Sumedh mentioned, right, you can sign up for a free trial for the Qualys platform. So it's not just container security, all the modules on there. So you can go sign up for that. So You can pick your champagne. You can go and read a blog. You can go read the product documentation, or the best thing, you can try out the product itself. So
I think you can go to qualys.com/containers/security, and that should get you there.
Outstanding. Anything else you would like to share with our audience, Badri and Sumedh?
Badri?
Containers are here. It's 2020. So if you think about it from a security standpoint, I like to think of it as a Maslow's hierarchy, if you will, of container security. Start with the foundation of the pyramid, which is really around managing your attack surface. I had a customer once tell me, and I'm quoting this customer, so the dream is to scan early, scan often, scan everywhere with one scanner, right? So once you have that foundation in place and you've managed that attack surface, then you can have very lightweight runtime security on top that doesn't defeat the purpose of the container. And the other piece I'll leave you with is no one skill set within the company will be able to do it all. It doesn't matter if you're a small startup or a large organization. You really need all these cast of characters, so to speak, to work together on this. Application teams need to work with their DevOps teams, with their security teams, to be able to make sure everything works end to end. So,
yeah, and I will add to that is that security is always defense in depth, and so you got to scan your images, you got to fix your libraries, you got to have developers writing the right code, but you do want to have this runtime layer as your final layer of defense to ensure that in addition, I should say, to all the things that you're doing, bad configurations or bad deployments are not eventually leading to have compromises despite all your efforts. So this is sort of the final bastion of security to ensure that anything that gets strained out through the earlier processes will be caught with the most basic ability to ensure that what you're not supposed to do as a container, you're not doing it.
Fantastic. Sumedh and Badri, thank you so much for coming on the show tonight, talking about one of my favorite topics, container security. For folks that want to learn more, we mentioned several resources. You can also go to securityweekly.com/Qualys and find all of the segments and information about Qualys. Thank you both again. With that, security news coming up next. Stay tuned.